Welcome to Drone Recipe. Thanks for tuning in to the channel. My name is Peter, and today we're going to be doing a 3-inch quadcopter build. This is an Airblade UAV Eclair. The Airblade Eclair comes in a couple different versions. I'm just on their website right now. And the only real difference between, there's a 3-inch Lite and then there's a 3-inch Pro, is that the side plates are half a millimeter difference. But the bottom plate is still 3 millimeters. As you can see there, so 2 millimeters for the Lite, 2.5 for the Pro. But I wanted to show you the backpacks, and there's two types here. Nonetheless, though, they're completely optional. I think they just add more weight, but they hold your antenna. And this one here, the large one, is made for the Mach 1 VTX, and the cheaper one, $10 Canadian, is just for any sort of VTX. But I bought one. I decided not to use it just because it was going to give me additional weight. Let's just open it, see what we have. It's 3 millimeters for the bottom plate. Then we have the two side plates. They're 2.5. And then we have some accessories over here. We have a battery strap. And let's see what they give us for screws. Excuse me. So nice little battery strap. It's kind of neat. A steel buckle though. It's not a big deal. I think that's a good thing actually, because I've broken plastic ones before. Now in terms of hardware, we have 1, 2, 3, 4, 5 nylon standoffs. 25 millimeters for these standoffs. And they give you 1, 2, 3, 4 of these M3, looks like 18 or 19 millimeters, 4 of those. And then we have 2, 4, 6, 8, 10 of these 10 millimeter. And then we have some nylon nuts. I always get the nuts and bolts mixed up. Some nuts, 4 of those. The TPU mount weighs 6 grams. Now the frame doesn't come in orange, but I chose to spray paint it just for better visibility. I've used these Matek dampening bobbins, and the reason why I've used those is, in addition to the dampening, is I want to have some room so I can get the battery strap through it and not interfere with anything. Okay, so what I chose to use was the Matek Fchub A5. That's complementary to this board here, and this is the 20x20 Matek F405 Mini. And this has a ribbon cable too. This power distribution board, as you can see, there's a backside to it. And there's also 8 holes, so if you want to mount it 20x20 or your traditional 30x5 by 30 by 30.5 millimeter. And this is where your ribbon goes. The flight controller comes with these silicone dampers and these optional adapters for a 2 millimeter screw, I believe. And with these clips, they just pop out this way on a 45 degree, and I push it flat to secure it in place. Now, like I said previously, I need to waterproof this. For all my connectors, I use CorrosionX HD. Everything else I use conformal coating, silicone conformal coating. Now for RX, I'm using the 5-volt Spektrum version, and as I mentioned, I already decased it. Just keep in mind, before you remove this, you have to bind it. Okay, so mine's already bound. So what you would want for this one is most likely the D4R, right? Because the pins are going to be here. And then have some two-way tape here. So D4R, what you do is bridge the D4R, the very bottom and the middle. I'll give you the power to the pins that you need over here, where it fits. So wherever it fits, that's where you bridge. Off the power distribution board, I'm going to have some nylon standoffs, just enough room so I can stack it underneath like this, and I want my VTX on the top. This is the ribbon cable right here, and as per the diagram, it's going to go in this way. Maybe it just doesn't go in as far as I think it should. And just press it down. Okay. This stuff is rather noxious. Like, the fumes are really bad. So I'm going to use my fan here, my soldering exhaust. If you had the option of going outside, I would certainly go outside. This is the one I like. Expensive. And what I like to do is just spray it into a plastic bag. Take a brush or something and just use that to coat. Use that to waterproof. Just the connectors. I was thinking about using, this looks nice I think, using these aluminum standoffs, but it's going to add an additional 5 grams. Compared to the nylon ones that you get. So if weight is not an issue, which in my case it is an issue, then you may not want to use this. I haven't decided. I mean, it looks nice, but this may take me over the 250 gram mark that I want to get to. I don't want to go over that for legal reasons. Now I'm going to show you the 5-volt CBS version 2 VTX. See, as you can see, and this is already coated, conformal coating. I broke off the connector here, but you see right in there, there's little slots. That's an alternative way to connect it, and the board gives the same pinouts here, so you'd put your wire right over there. That's what's going to power the VTX. You solder that down. You solder the whole thing down, bud. So just flick it up. And just simply, just put a little bit on here. Like, I can really save this part right till the end, but might as well do this part. Let's flash this board. Okay, let's just go into Betaflight, plug in the USB, press connect. You want to enable expert mode, and just to have it in mind to press calibrate accelerometer, and also get my axis right. Now we're going to go into and just check the sensors here, see if everything is okay. I'm going to go into the CLI command and we're going to type in version. So that should give you the current flash version on your flight controller. Because who knows, it could already be flashed to the latest, so it's always good to check. Then go ahead and press BL, so Bravo Lima, and that should boot you out, but also put you into DFU mode. And in this instance, it didn't happen, so it's very common. What you want to do is download Impulse RC driver, install that, and use that to put your flight controller into bootloader mode. Once you have the Impulse RC driver installed, run the program without the flight controller connected, and then connect it by either pressing the boot button or shorting the boot pad, and you'll see on there that it's installing the DFU driver in order to put it in DFU mode so you can flash it, because it does need to be in DFU mode in order for you to flash it. Now once the flight controller is in DFU mode, and you can tell by looking at the top right hand corner of Betaflight, is go into Firmware Flasher and choosing the right flight controller. So in this case it's going to be Matek F405 Mini, and you can also go to the Matek website to get it as well, and it's always good to confirm by going there. And we're going to pick that target on Betaflight, so we're going to scroll down. First pick the flight controller, and then we're going to pick the latest version of Betaflight, full chip arrays, load firmware online, and then we're going to press flash firmware. So once it's flashed, reconnect, and now we're just going to confirm the version of firmware that we just flashed. Go back into the CLI command and again type in version and enter, and you should see Betaflight 3.3. Now there are some additional CLI commands that you need to input if you want to use camera control, that is to control your camera settings on your FPV camera, and also for smart port, and that really applies to SBUS users who want to enable telemetry. Now we're going to take these pin headers, and then I'll do the same here. So then, oh, did I do it the wrong way? No, I didn't. Just take these. Come on. Come on now. There we go. It fits. Let's get some double-sided tape. Right. I'll just peel that off. Come on, we can do it again. We did it before. And here we go. Bam. So then we go to the back of the board. First I'm going to do the pins. Okay. Good bond, and I want to choose, iron's a little bit too hot. these two guys here. If you can see that. So this middle one and this one. Yeah, so like I said, the only thing I don't understand, because this allows you to use different voltages for both, is this little bridge. I don't really understand what the hell he's talking about. Alright, so what are we doing here first? Just tin it, if you will. What else can they do for? Pressure, I don't want to get that too hot. That should be good enough. There's actually one more, but I think it should be alright. So you want to tin these up too. And this is where you put your Spektrum wires from the flight controller. You might as well tin these too. This is harder than it seems, you know. You can use a little bit of wire if you want it, but there we go. Oh, she's hot. I'm going to tin up the VTX, the ground, cam, the ground, and I think I'm going to do the TX3, which is for smart audio, I believe. I'll double check, pretty sure. And for the, like I said, I'm going to use a negative on the flight controller and also on the power distribution board. Probably better if it was secure. There's your positive, negative, and your signal. Alright, excuse me. Up there. In the 5-volt for the VTX or something. We're not going to use the telemetry. Here's the VTX. Where the VTX goes. Ground. volt here. Another V-band here. I don't know this one. This is for UART5. If I bridge these two. Now, if you are running BLHeli32 ESCs and want a telemetry from them, all you need to do is bridge those two pads right beside the RX5, the receive 5 pin in the white bracket. So once you do that, telemetry will be enabled through the actual ribbon cable. And here's another diagram of the same thing, just through a different perspective and with some wires attached. So now what I'm going to do is I'm going to mount this, which has been waterproofed or silicone conformal coated. Make sure the orientation is the same. So signal 1 is here. So just put it right up against the holes, right, like that. Just like that. Get it nice and even. And then take those screws and push them through this way. And like I said, they give you a few extra. I think there's 2 extra. There's one here. I think I've lost one already. It's very typical of me. Consider there's a few extra. Should have no trouble, okay? So this is how it goes. So now the screws are through, and just enough for the nylon nut. You don't want to over tighten these. Let's put this on. These nylon standoffs to give some support while I'm soldering in the ESCs, and it helps me route the wires too. Close up of the ribbon cable. So I'm going to take out some of the CorrosionX real quickly and just put a little bit of that on there. Maybe a little bit more. Beautiful. I'll take these, I guess, if I wanted to. Just helps me out. It's a little bit slippery now. And I think I'm going to have to remove this one here, just to make it easier. These tweezers are anti-static, so but still, I don't want to press too tight. There we go. There. Once you got that in there, just use your thumb or something just to bend that stick down. Because you don't want to put any silicone on here, because then you'll never get it out. Stuff stinks. There. Protected. So we can start with this ESC right here. As you can see, both the signal ground and power ground are already soldered together. The signal wire goes here, as you can see that. So I can probably afford to clean this up and retin the wire. Take a little bit off like that. Stop strip some fresh wire. Just be careful, you know, it's easy to strip the wire here. There we go. I'll show on one, and then I'll just do everything in fast motion. Oops. Shoot. There. There we go. Let's put the positive in. And these two negatives. Kind of a pain in the ass because it's two. Oops. Okay, so that's one, and I'm going to do the same thing to all four. To these pads too. Alright, so here's one. Hopefully this doesn't light up. Should hear the motors. I've used just one zip tie on the neutral for some strain relief. I'm not going to use big batteries on this anyways. So you see R2 there, that's where the data wire is going to go. Okay. And this receiver is going to be using 5 volts. So right beside the SBUS, and there's one ground there. Okay, so let's attach those on. Let me see if I can do a through hole. There we go. That's going to do just fine. And lastly, I'll do the ground. Might be a little bit easier to remove all these standoffs and such. It's fine. So we got these. So these are ready to hook on to the Whitenoise board. Let's turn this around. Okay, and let's 10 TX3, that's for your smart audio. So TX3 is for your smart audio. Right here. And then you have a ground, VTX, cam, ground, and we're not going to use the 5 volts here. Okay, so now I tinned where the TBS Unify is going to be, so the VTX, and the TX3 again is for the smart audio, ground, VTX, and then we have the camera and ground. So I have some wires here that I just took. I mean, you can use any wire. I gotta tin these up. So I'm going to use the white for smart audio. Just keep consistent with the color schemes. For the cam I'll use yellow if I find it somewhere. We're going to harness the power, so we need the red one, from the power distribution board. Based on the continuity, the power will go where the negative is, and the ground will go where the 5 volt is, and the data remains the same. The negative and positive pinouts for the Spektrum receiver compared to the FR Sky receivers are reverse, so it was just intuitive enough for me to do a continuity test to find out. Okay, so basically I'm trying each thing step by step, and I attached on the receiver, but as you can see I reversed the pinouts on the power and ground based on my continuity test. So what I'm going to do now is I'm going to use my smoke stopper and I'm going to plug it in, get my transmitter too, and let's see if we get a short. Magic smoke. Let's change this. Oh! Maybe I didn't do that much damage. Alright, so I have my camera leads. I'm not going to be taking the power source from the flight controller, as Matek recommends not to. So we'll use the camera, that'll be the yellow. Then we have ground. I figured I'd put the camera wires on and at least try the VTX with a camera attached just to see if I can get a video feed before I threw in the towel on that TBS Unify. Because I don't see any LEDs or anything. Okay, so I removed the whiteboard. VTX was all burnt out. I managed to salvage this, so I just soldered onto where the JST plug was. It's a little closer fit, but still can be done. Obviously, the light is on. It's still bound. And now we're going to try and add a brand new TBS Unify 5 volt. Oh, alright, so we're going to go a different route this time. Instead of soldering onto the Whitenoise board, I did screw up on it. I'm just going to use it for a heatsink and to make things a little bit tidy. So I'll have the same thing. I'll have the RX, my receiver Spektrum, underneath with some 2-way tape, and I'll have this on the top. But everything's good. I have a video feed on my goggles, and I just need to set it up and configure it on Betaflight, and we're all set to go. It's a good idea to have the Matek website open just for cross-reference while you're setting this up on Betaflight. UR2 is going to be your serial RX, so that's what you're going to use, unless you're using PPM, and you don't need to do that. But not many people do compared to the other protocols. Now, smart audio will be enabled on UART3, as I'm doing here. Sure, save and reboot so that the changes take place. and UART 5 is for ESC telemetry. And lastly, we have the smart port option for SBUS users who have telemetry or want to enable it. But since I'm using Spektrum, I don't have to worry about that, so we're just going to bypass it. Under the configuration tab, you can set your gyro and PID loop to 8K and 8K if you'd like. I actually had to reduce the PID loop to around 4 because my motors were getting hot. Personalization, you can add your drone name or whatever you want, really. Now the arming angle is set to 25 by default. I just changed it to 180, which means I can arm it at any angle. It's just a safety feature. If you go down to the receivers, I'm going to pick the Spektrum, obviously, because that's what I'm using. And under other features, this is where you enable soft serial, telemetry, OSD, and I also enable anti-gravity, dynamic filters, air mode, and I don't need soft serial because I'm using Spektrum. And these are the beeper settings. I just turn them all off. I don't have a beeper on right now, but I do suggest that you might want to get one, or you might want to use your ESCs for the beeping, but I don't recommend that. Under ESC protocol, you're going to pick D-Shot 600 because it's BLHeli-S that I'm using. And for idle percentage, 5.5 is what I use, but that's a preference. Now we're going to save and reboot. Connect and go to the power and battery section, and that's where you set up your current sensor and voltage alarms. The next tab will be failsafe, and what I like to do is make sure it's on drop and make sure that the kill switch is enabled. On the PID tuning tab, what I recommend is to keep it on defaults, but if you want to set it up the way I do, well, what I like to do is just to decrease the derivative a few clicks and increase the proportional on the roll pitch the same amount, and also to increase my yaw. I also increase the RC rate, as you can see there, and also the super rate. Next step on the same tab is to go to filter settings, and from biquad to PT1, remove the first two notch filters, save. Next, go into the receiver tab, and by now you should have your radio bound to your transmitter. Now pick the right channel map according to whatever radio protocol you're using, and here's just a layout of the things you need to consider when you're on this tab. Basically, you want to ensure that the roll, pitch, yaw, and throttle, represented by the top bars on the top left-hand side, are the same on the radio. And you want to adjust the low, mid, and high, so that's 1000, 1500, and 200 PWM value. Okay, and if you have the wrong channel maps, this is where you'd find out. On the bottom right-hand corner is a picture of your drone, and you can test it out with your radio to see everything's okay and if it matches. If it doesn't, that you might have to change channel maps, and if you don't get anything at all, then, and if you're using a different flight controller, you may have to change something in your ports tab. And just keep in mind that when you do that, you should save it, because the changes won't take until you save it in the ports to see whether or not it's connected to your transmitter. Now, to the modes tab, I basically have two 3-position switches, and one's used for failsafe beeper, but there's no beeper attached to this one. And to arm it, so I would use one channel. So in this situation, you can see under the drop downs, it's under auxiliary 2. Okay, so I'm going to have a switch that matches to that. And then my second 3-position switch is my flight modes. Okay, now we go to the motors tab, and please ensure you don't have any props on. And this is where you can test the direction of your motors to make sure that they're right. On the OSD tab, now since we have an OSD on the flight controller, we're able to use it. And just pick whatever you want, or whatever is relevant, and whatever you're capable of, right? So you're not going to pick a GPS reading if you don't have GPS. And it's very simple, pretty straightforward. You can actually, in the square, drag and drop where you want these indicators to be. Now the last thing we're going to do is we're going to save it in the CLI command, but we're also going to set our min and max check. Here, I guess, it doesn't really matter. It's not being soldered on. And this guy is going to go on the top. And I do want to attach, I'm going to take this off for a moment, a zip tie around this, so I hold this in place. It's going to be right up against the side here, so we can do it that way. I'm only going to put a little bit, because I want some air to get through the bottom. If you totally cover this with tape, you probably will have some heat issues. And you may not even need tape, you can just use a zip tie if you wanted to, right? And why is it not? It should be alright. Just like that. Like I said, you can use some, you can use a zip tie. They're all even. Here's the two side plates. So you can decide whether or not you want to use the nylon ones that come with the package, that come with the frame, or you can put some aluminum ones like I'm doing. I'm just doing it for looks, obviously. Now it does add an extra 5 grams. So this could be the difference between going over 250 or not. I really should be using the nylon ones. And the camera goes in here. So I'm just thinking, where can I add some zip ties for the antenna? Now I have everything, I have the side plates on, I have a zip tie, and I'm going to use blue just to keep with my geeky color scheme here. And now I'm going to protect the antennas by placing some heat shrink over that. Well, you have a little bit of slack just in case it hits the ground. You don't want it to tear off. We'll put another layer on there. Give it some extra added reinforcement. Just gotta fix the camera. I'm gonna secure this. I don't want it to touch any metal. Usually I would heat shrink that as well. We'll see what we'll do there. This is gonna be the antenna. Alright, so it looks like I messed up a little bit. For some reason I thought that I would need the micro, so the run cam micro size, but it turns out that it's the mini size that I need. So my bad, and I'm just going to put this mini here. Okay, so I took off the Foxier antenna. I saved a lot of weight here, and by removing the blue standoffs here. Place the capacitor on there, and the antenna is just a whip antenna. This is from an Amway whip. So let's take a weight here. For example, this already is 192. Now if I were to slap on this battery here, which is 450 milliamp, and it's 45C. Alright, just take my word for it. These motors pull each at max 12 to 13 amps. So, you know, you're looking at 40 amps, and this can only deliver around 20 something. But this one here, this one has an XD30, which I would change. This is 650 times 70, and this will give you around 42 amps, right? So that's what it can deliver. This would be a better choice. Weigh that. Look, we're already at 280. But if I use this 450 milliamp, that 8 is really a 0. There's something wrong with my scale. 250 grams. Can we doctor this? And ideally that battery isn't good enough. Not a matter of quality, it's the capacity of the battery is just not enough. Right? Because as we all know, the capacity times the C rating, even though C ratings can be exaggerated sometimes, a lot of the times, who knows how many times, that would give you the available amperage that the battery can give at one time. So always go for the higher rating.